Cool. I guess we're ready to go. It's live now, so just thanks for being here if you're here already. Been waiting or whatever. But yeah, it's good to see you here and looking forward to talking. Hope everyone's staying safe at the moment and staying at home, and working from home is working out all right for you. So I'm going to go ahead and share my screen and get started on the talk for today. Just set this up. Cool. Right, so if you can see my screen there. Cool, so today we're going to be talking about GitHub Actions and using it as a continuous integration service for Android projects. In this talk, we're not going to be going too deep into GitHub Actions itself or surrounding topics, but we're going to be sort of taking a look at a practical approach at the ways I'm currently using it at my company, and that hopefully will influence you or inspire you how you could use it yourself in your own projects. If you want to tweet during the talk, you can tweet me at Hi There Joe on Twitter. And yeah, with that in mind, I'd like to get cracking. So, continuous integration and delivery. This talk kind of touches on these kind of topics. Continuous integration and delivery is quite a big topic in itself, but it's quite a large concept. So in a nutshell, this is essentially allowing us to continuously deliver values to our user, reducing any kind of friction that involved when it comes to building, testing, and deploying code. At your company, you may already have these kind of solutions in place. You might not, but if you haven't, it's definitely worth thinking about. There's a lot of benefits that you can see from these things. So rather than having someone who is solely responsible in your team, for example, for building releases and uploading them to the many app stores that we have, you can have tools that will do that for you. So external services which will build, test, and ship your code for you. These can then also run on your pull requests and so on, and it also gives you that peace of mind when you're merging and shipping code. For this kind of things in place, there's a bunch of services that currently exist. You may either have used some of these, or you may be familiar with them already from some other means. We have tools such as Bitrise, Travis CI, Circle CI, which are hosted tools which you can connect your GitHub projects to, and GitLab and so on. And we also have more self-hosted approaches, such as Jenkins, which kudos to anyone who has set up and maintained a Jenkins instance. There's a lot more work involved, but you do have a lot of control. And these services work great. There's nothing wrong with these. Every own team has their own needs, and every project has its own requirements. At Buffer, we previously were using Bitrise, and we still are on a few of our projects. Nothing wrong with it. It's been a great tool, and it's worked really well for us, and it's a good price. However, I think it's good to be open to new technology that comes out if it makes sense to your company. You could either save money, you could have things run quicker. It's good to keep your eyes open and explore new avenues. And this is kind of where GitHub Actions comes into things. GitHub Actions isn't a super new technology. I think it was sometime last year, it was put into beta and gone into stable release now. I knew about it from the beginning, and I was always kind of curious, like, what could we use this for? At first, I thought maybe it's just small automation tasks like labeling things or adding people to projects, but you could do a whole world of things with it. It's basically kind of in the background. It's basically the same kind of thing that you're currently using for your other CI services, just with less of a graphical user interface. So I knew about GitHub Actions and kind of got a bit curious about it. And I noticed that at Buffer, we had enough allowance in our GitHub account to support the mobile team at Buffer. I think we're on the team plan at GitHub, which gives you about 10,000 minutes, which is a lot of time. So if we're going to hit 10,000 minutes a month, something's probably going on. But because we already had the allowance, it meant that we wouldn't have to pay any more to use it. And at Bitrise, we're paying $175 a month, and that's for free concurrencies. So if 4 of us open a pull request at the same time, the 4th person who opens that pull request is going to have to wait until one of those finishes, unless we pay an extra $50 a month. And if our team grows, or if we need more concurrencies, that could get quite expensive. So kind of thinking ahead of it, we decided to start making the move and make use of something that we're already paying for and we already had the allowance for. So I started to do some research into GitHub Actions and take a look at what kind of stuff is possible. And when it comes to actions, like I said, you can pretty much do anything that you're currently doing in your existing CI services. You have access to the underlying system. These are just running on Docker containers, running on Linux machines, and so on. So you have exactly the same control and ability to do the things that you're currently doing for your projects elsewhere. This could be things such as running checks on your pull requests when they are opened, or maybe when they are reopened, or killing things off when they're closed. Maybe you're running unit tests, maybe you're running lint checks, maybe you're assigning people to review those PRs, maybe you're running danger, and you can do those things with GitHub Actions. You can handle release flows. So if you need to upload builds to the Play Store, to the App Store, deploy changes to your website, you could do that when, for example, releases are tagged or new releases are put in GitHub, or when a certain branch gets merged. You could build, sign, and upload an APK to Google Play, for example. We could also run scheduled tasks at certain times. So if I want to run something maybe every Tuesday, I want to release a new beta release, or maybe every Thursday we want to do a new production release, you can essentially run cron jobs for GitHub Actions as well. Yeah, and pretty much anything, just to reiterate the idea, there doesn't feel at the moment like there's really any constraints when compared to other services. So before we get started at what we're actually using GitHub Actions for at Buffer, I think it's important to cover a couple of key topics, key concepts, just so that when I'm talking through the things that we're using it for, there's a kind of bit of understanding what is happening. So one of the first things that I previously touched on earlier is there isn't kind of a graphical user interface when it comes to GitHub Actions at the moment. Maybe there will be in future, but everything is kind of just written in a YAML script. So it's kind of just you define a set of tasks or things to do as a YAML script, and you can easily jump in, modify that, and add things. There isn't any kind of concept of drag or dropping things into place or reordering things like we see in other services. I did quite like that with tools such as Bitrise, but I find that having a direct access to this and it not being clouded and also inside of the UI that I'm familiar with, I feel like I have a lot more control doing that. But that could be down to personal preference. You can edit these locally, you can edit them within GitHub, depends what suits your preference. On to these key concepts. So the first, probably most important thing is a workflow. So a workflow is essentially a set of instructions that you want to trigger when a certain event occurs. So it might be a pull request, a release, or even a weekly scheduled task. And the workflow essentially defines all of the operations that will occur when a specific event occurs. So it's kind of like a modular approach to a set of tasks. So for example, at Buffer, we have a beta release, we have a production release, we have a pull request, and these are 3 separate workflows that each contain a set of instructions that should run whenever those events occur. We also have triggers. So a trigger is defined within a workflow. The trigger declares what will cause the workflow to run. So for example, we use this on attribute to declare when what that workflow should be run on. It could be a pull request. Maybe it could be a push event. So you can also narrow that down even further. So whilst at the top we have just a pull request event, that's for any pull request. We could also narrow that down for pull requests on specific branches. And as we can see below, where we're listening for push events, we could trigger this workflow when a specific tag is used or a specific release is used. And alongside this, we can also use schedule triggers. So using a cron job format, we can have certain workflows run when certain trigger events occur in the form of a schedule. So every workflow has a trigger, and that tells it when that workflow should be run. So we also have the concept of a job. So a job is essentially something inside of a workflow that is going to be run. So an example job would be run my unit tests, or upload this build to Google Play, or clean my project. Those are all jobs that will happen inside of a workflow. So just to iterate on that a bit more, we have a workflow. We then have a trigger, which that trigger is used to tell the workflow when it should run. And then inside of that, we can have one to many different jobs that will run inside of a workflow. And as far as I know, well, I haven't discovered any limit to jobs that you could run in any workflow, but it's good to split each task into a separate job just to keep things modular and easy to maintain and work with moving forward. So on that note, real world use cases. So we're currently using GitHub Actions, I guess in production, we could say. We're using it on all our pull requests. We're using it to ship releases to Google Play Store on both the beta and production tracks. And we also have a scheduled job that runs once a week, which we'll come on to later. So we are using this to ship things to real users, and it's working out well for us so far. I'd like to look at a few of the things that we're using it for, beginning with a pull request workflow, which seems like the most obvious thing for us to start with. So this is whenever a member of our team opens a pull request, we want to run a collection of checks on the code that is open inside that pull request. So to begin with, we open a pull request, and we currently have 2 jobs inside of there. This could look different at your company. At the moment, we're only running unit tests, and we're also running danger checks. So unit tests is to run all the tests on our project, just to check nothing's broken. And then danger, if you haven't heard of it, it's essentially like a linting tool. And what danger will do, it will add comments to our pull request so that it saves a human adding comments for obvious things, like whether it's linting errors or commonly known Android bugs. Danger helps us with that to reduce the cognitive load on a reviewer. If you haven't heard of Danger before, I recommend checking it out. It's a really useful tool and really well maintained. So to begin with, let's jump inside of our workflow file for a pull request. So to begin with, a workflow needs to be given a name. Best to keep this descriptive. When you're inside of the Actions console inside of GitHub, naming is essential if you'll need to jump between things and find errors and debug your code. So we need to give a name, and that begins with pull request because that's what we're doing here. This is our workflow. Once we've given it a name, we need to define the trigger, which we previously mentioned. So the trigger is when this should be run. So in this case, we want to run it on any pull request because we're using the same pull request flow regardless of what pull request is opened. So we're going to run this on any pull request. Again, like I mentioned before, you could nail this down even further, and you could define specific conditions as to what pull request and what branches should be used for that check. Then we come on to jobs. So as I mentioned, for our pull request workflow, we're only running 2 jobs, and these are then defined in the form of steps. So our first step in our jobs is our test step. So we can see here we have our test step, and again, that is just breaking things up into separate layers inside of our jobs clause. So begin by giving our first step a name, and again, when debugging, this is really important to give useful and easy to understand names, not too long, nice and concise, so that when you're debugging code, you can find them quite easily. So we're going to begin by giving our first step the name of run unit tests, and we're going to declare the machine that it runs on. So you can run GitHub Actions on essentially 3 different machines, I think. It's either a Windows machine, a Linux machine, or a Mac OS machine. If you're doing Android stuff, in most cases, you should be able to just declare Ubuntu latest. That just means you'll be running your execution outside of a Linux container. If you're doing iOS projects, then the Mac OS one. But be important to note that the Mac OS container is a little bit more expensive to run, and it will use more minutes just because it's more pricey. But if you've got a 10,000 minutes a month, then you should be able to account for that. When it comes to declaring the machine that you run on, you can declare specific versions, but if you're not need to do anything specific, or there's not any specific cases or reasons why you need to use a specific version, it's best just to use the latest tag so you can ensure that you're always using the latest versions and you don't have to manually update stuff. And once we've declared what machine we're running on, we can go ahead and start adding the steps for our job. So our first step is going to be the checkout step. So you're probably going to use this action inside of most jobs that you declare. And this is an official action, and this basically checks out our code, our current branch. So whatever branch's pull request is running on, this action is just going to check out the code so it can be accessed by our job. Nothing fancy here. You don't need to do anything else, but if you're accessing code within your job, you need to check out the code using the checkout step. Once we've done that, we then need to set up the JDK. Because we're going to be running our tests, we're going to be accessing Java or Kotlin code. We need to ensure that the Java is set up on our environment so we can run our tasks on our Android project. So here we're just going to use, again, another official action for setting up Java. We're going to declare the Java version that we want to use, and that's going to run for us. So at that point, we've checked out our current code, we've set up Java on the machine, and then we're going to run our unit tests. So the nice thing about this is when it comes to the last part of this step, is we're just going to run the same command that we'd essentially run from our command line. And that's one of the things I like about GitHub Actions is that although we get a lot of magic with our CIs, this is kind of, we can declare exactly what we want to run, and we're using things that we're already familiar with using on our machines. So here we've got our entire unit test job, checking out the code, setting up Java, running our unit tests. If our unit tests fail, then this whole step will fail, and then the job will fail, and it will show as a failed status on our pull request. So that's really nice. So we won't be merging in any code if anything goes wrong, hopefully. So now we've got our unit tests job defined. If you remember, on our pull request, we did actually have a second job, which was danger. It may be the case that you don't have anything like that and you just want to run your unit tests, that's fine. But when it comes to jobs, we could define another one and use that at the same time. So we're going to have two jobs. We're going to have test and we're going to have danger. Don't want to go too much into the danger one itself, but this is essentially what it looks like. Just to show the similarities between each of the jobs that we're defining. We have a name at the top. We declare what machine it runs on, and then we define a collection of steps that are going to be used in that job. So again, we check out the code because we need access to it and we need to have that on our environment. We then set up Ruby because danger uses Ruby to run its checks and to run its script. We're not using Java, so here we just need to set up Ruby, again, defining the version that's used. And then for this last part, you may notice that this isn't an official action. We're using this by this username, mail CLI. I'm not sure that's pronounced correctly, but this is a community action. So one of the cool things about GitHub Actions is anyone can make a GitHub action. It has to be verified. So I think for security reasons, you can't just make one and chuck it out there and have it used by anyone. But there's a lot of community actions that exist, and there's actually a bunch of Android ones, which we'll be looking at in a bit. But this is a community action called Danger Action, and this actually made my life a lot easier by just being able to provide the provided arguments, the required arguments, and which would run my danger checks for me. So that was really nice and easy that was someone had created that, and I could just use it out of the box. So that's kind of that. That's our pull request workflow. So we had our tests, we run danger. If that's all good, our pull request will be green and it can be merged in. So whilst going back to the unit test, whilst that maybe look like a little bit more than dragging and dropping a unit test step into a GUI, this allows us to have a little bit of control, and we can do custom things when it comes to running this. So being able to just run pure bash scripts or any kind of scripts inside of our action gives us control. Like, for example, at Buffer, we have our own script. I haven't got it here, but it basically checks for the changed modules in our project that are in the pull request, and then it will only run the tests for the modules that have changed. That could be down to personal opinion, like some people might want to do that, but because we have that script, we can easily just run that here. We can run kind of anything that we want to that could be run as a bash script. So, and that was one of the really actually easy things of moving over from another service, because a lot of our stuff in Bitrise was custom scripted. It wasn't much hassle to move over because this is kind of just removing that front end kind of thing and just allowing us to run those pure scripts ourselves. So it's kind of quite simple for us to move things over. So yeah, we've done our test, we've done our danger, and that's our pull request flow. So the next flow is actually our release flow. And this is actually the first one I built into GitHub Actions because it's our most complex flow. And I thought, if this can work, then we can get anything else working. So this is essentially, the way we had it working previously was when we tag a release in GitHub, we kicked off a build in Bitrise, and we uploaded, once everything had done, we uploaded that build to the Google Play Store and using the tag, the version of the tag. And we had two workflows that run, a beta release workflow and a production release workflow. And now we have both of these in place in our current projects in GitHub as well. So what does this look like? So when we create a new tag, that's our trigger. We then have to do several things. We have to update the app version, so that involves committing code into the repository. We then need to run our unit tests, which is the same as what we previously did before. We then need to assemble the test APKs. We then need to upload these test APKs to Firebase so that they'll be run in Firebase Test Lab. We then need to build and sign a release APK. Then need to upload this APK to Google Play Store. And then we need to post a message to Slack, the most important parts, that we know that release has gone out, and maybe your QA teams or PMs know that a release has gone out and can start accounting for that. So let's begin by building this workflow for a release workflow in GitHub Actions. So again, like before, we're going to name our workflow. So this is going to be production release, because this is the production release workflow, so we're going to give it that name. And again, we need to define when this should be run, so the trigger for this workflow. Previously, the trigger was pull request, and now this trigger is going to be, we're going to want to run this on a specific tag. So our version numbers are number, period, number, period, number, period, number, period, number. So basically, we tag that when the release wants to go out. So using GitHub Actions, we're going to listen for that tag. And whenever a tag occurs, we're going to run this workflow. And this is what we've defined here by this regex style declaration for the push tags clause. Our beta one looks very similar, just to handle an RC tag at the end. So when we tag for a production release, we're going to run this workflow and run a collection of steps with it. So a collection of jobs, and our first job is going to be generate a release name. So there are quite a few jobs here, and we go through each one by one just to have a good understanding of what's happening. So again, as before, we defined our job and we've given it a clear name so that we know what's happening. We then need to commit the newest version to the code base. So we've tagged our release and we need to commit this to our build.gradle file so that when we build the release, that new version is accounted for and it can be uploaded to the Play Store to behave as an update to the previous version of our app. To begin, again, we're just running some scripts here because we have complete control over what we want to run when it comes to scripting. So we're going to retrieve the latest version by running a git command. This is just fetching a collection of tags that match the defined pattern, and that will grab the latest one. We're then going to use some sed or sed commands to take our build.gradle file and replace the version name that has been defined in our build.gradle file. So what's happening here doesn't matter too much. It's just a case of updating the version. And then once we've done that, we're going to then want to commit that file to our repository so that when we build the APK, that new version is accounted for. So we've got the newest version, we've changed the version in our build.gradle file, and then we've committed that to our code base. And once we've committed that, we then need to push our changes. So again, we have another step, which is called push changes, and we use this community action, which pushes all of our changes to the defined branch. So here, we push our changes to the beta branch, and we use our GitHub token to do so. So if you're dealing with actions or community actions or official actions that need a token to communicate with your repository, maybe it's pushing, pulling, or committing stuff and whatever, there is a built-in environment variable called GitHub token, which has access to do those things. And you can access that using the format that you see on the screen there, which is a secrets.github token. And one of the nice things is you can, inside of GitHub now, you can define your own secrets, and these can be accessed in the same way. So if you have a secret called myAPI-key, you can do secrets.myAPI-key, and you can access those values from within your scripts inside GitHub Actions. So if you're dealing with API keys and stuff, you can store them securely and access them in your project. So in this first job, we've defined a collection of steps that will update our version number, and now that's ready to go on to the next one. So as before, we have the unit test, and currently we just copied and pasted this. I'm currently trying to find a way to reuse steps and jobs across workflows. As far as I know, it's not possible yet, but I'm trying to see if there's any way around that. So we have our unit tests, and one thing to focus on here is this needs declaration. So previously we had our unit tests in danger. They didn't matter what order they ran, they could run at the same time. It doesn't affect one another. But if our generate version name, update version name step fails, we don't want to continue on to the next thing because we won't be able to release the build anyway. So what we do here is we say that the run unit test job needs the build job. So our build job was this one. If this passes, this succeeds, then we go on to this. And this unit test one will run after build. And so if you need something to run in that kind of sequential manner, you can use the needs declaration to do that. And again, we define the machine or the system that our action is going to be run on. We check out our code and we run our unit tests, just as we did before. Nothing different going on here. And then once our unit tests have passed and everything's good, we're going to go ahead and configure what we need for our UI tests. So if you're familiar with running UI tests on Android, you need two APKs. You need a debug APK, and you also need an Android test APK. So we're going to go ahead in this job, we're going to build those APKs so that they can be provided to Firebase to run those tests. So again, we use the needs clause to say only run this if our unit tests pass. And then we define some steps which build these APKs ready for use. So we begin again by running our gradle assemble debug command. As an example's sake, I've added a stack trace attribute here. So if you need to log more things inside of your commands, then these will be logged out into the actions console, which you can just access from your GitHub repository. And once that's built, that APK will be placed in the same directory that it would be if you run that locally. So we can then go ahead and provide that to where it's needed. So what we've done here is we've got this job here is the build APK job, and the next job is going to be responsible for running the Firebase tests. And because we've got that modular fashion, we need to make that APK accessible to the next job. So each job will run in its own container. So that means any data that is created or modified in one job will not be accessible in another job unless you add it as an artifact to the build. So what we do here is once we build that APK, we then upload it as an artifact, and that attaches it to our workflow instance. So we'll go into that more in a bit, but what we do here is now that we've got that APK assembled, we attach it as an artifact so that it can be accessed by another job further down the line. And one nice thing about this is that, say you have a QA team, or even yourself, you want to go into GitHub and you've built something, a UI test that failed, and you want to access the artifact that was run for those tests, you can jump into your workflow and just download that artifact and install it on your device. That's another nice thing, like it doesn't get lost, it's attached, and even if the workflow completes or fails, it will always be there. We're going to go ahead and do the same thing for our Android test APK. So we're going to build our Android test APK, we're going to upload it as an artifact, and then pass the required data that is used to get access to the path for that artifact. So both of those have been uploaded and they're attached to our workflow instance. So that means they're now going to be accessible by the next job. Again, you can't run the Firebase job without having the APK job, so we need to wait for that. Download artifacts code. we'll come on to in a bit. It's kind of the same as it was before. Instead of uploading, we just use the download artifact action, and that will download it and attach it into the directories that we need. Then to run those tests on Firebase, we first need to log into Google Cloud and sort of connect the dots between Firebase and Google Cloud and our GitHub Actions reference. So again, we're going to use an official action, which is allows us to connect to the Google Cloud instance. And this is here where we're using reference to our Google Cloud authentication key from our GitHub secrets. So as I mentioned before, we had the GitHub token, which is a built-in secret. And now this is a secret that I've manually added to our secret store inside of GitHub, which is kind of just like a key value mapping. So once you've added that key value pair, you can then access them through the secrets declaration. So that keeps any sensitive data outside your repository, which again was one of the main concerns that I had initially before moving. And then once we connected to our Google Cloud project, we need to set the current project to our Firebase project so Google Cloud essentially has the APIs defined for like connected to Firebase and viewing our Firebase results. So that's where we have to link these two things. So again, we need to set the project. And then once we set the project, which is our Firebase project ID, we can go ahead and run our instrumentation tests. So here, this is a command line tool, which we can run on our local machines as well. And that's another nice thing. If you're running into errors here, you can easily recreate these situations on your personal machine and debug things locally. So we provide the path to the APKs that we've previously, which are now attached as artifacts, and they are run on Firebase test suite. So that will run and that will wait for it to complete. If it passes, it will move on to the next job. If it fails, then we'll see in our pull request that something's gone wrong, and we can view the results within GitHub Actions console itself. Next, if our UI tests pass, then we need to build an APK that is going to be released, uploaded to the Play Store. Begin by, again, adding the needs declaration. We don't want to build an APK if our UI tests fail. Maybe you do. It might be different per situation or per company, but if UI tests fail, we want to know why, just in case we put out a bad release. So begin by using just a simple pull command. So you may remember in the first step, we changed the version name, the version number of our application. Because this is all checked out at the same time, this job won't yet have those changes because the code hasn't been pulled. So if you make changes to any code in any of the jobs, you'll need to pull the changes in the next job that wants to use those changes. So begin here by putting those changes down and ensuring that we have the latest stuff in our virtual branch. So next, it's likely you're using some form of secrets in your app, whether it's API keys or whether it's references that you kind of want to keep out the code base. I know the way we do this, and I know a lot of other people do this, is by having values stored in their local properties on their machine or locally, and then referencing these as build config fields in your project. When you do this, when you have them in your local properties, that isn't going to be stored, I hope, in your repositories. If they are, then that could be a security concern. So at the moment, our repository has no clue about these API keys and secrets that are referenced throughout our project. So that means if we build an APK, those keys will be missing. So what we do here is, what I've actually done to work around this was we create a new file, virtual file. So when we create a file here, this is going to disappear as soon as this job's finished because we're not going to commit it. We're just going to add this file and then build our APK. And then once we've moved on, that file will go. So what I do here is I essentially recreate what we have in our local properties, give the names, and then I assign the values to the names using the GitHub secrets approach as we saw previously. So I have these buff API key, buff API secret defined within the GitHub secrets, and then I reference them from here using the secrets.name approach. So we create this local properties files with these values, and that's in place for the current instance. We then build our APK, so we assemble a release build. So that's now got a new version name and number, and it's also got this virtual local properties file that has our secrets stored in it. Next, we're going to use another community action, which is going to sign our release. So this will take the release build we've done, again, using a collection of secrets that we have stored in GitHub securely. And then once that's complete, we're going to upload the artifact to attach it to our workflow. So that we have our signed APK, and that's attached to our workflow. So then we go to the next job, which once the build APK is complete, we're going to upload the APK to Google Play. So at this stage, again, we're going to deal with code, so we need to check out our changes. And then we're going to download the artifact. So this was omitted before, but just to keep the code more concise. But similar to how we had the upload artifact before, we now have the download artifact action, and that will download the attached build from our workflow and place it for use in this job. So we basically just declare a name that we want to assign to the file, the name of the file that we want to retrieve, and we called that app release in the last job. So we're going to reference that here, and that will download it from our workflow. And finally, we're going to go ahead and upload this release to the Play Store and give access to it for our users. So again, this is made by the same person who made the sign APK step action. And what we're going to do here is we're going to use another secret from our server's account, use our package name, point it to the release file, and we're going to define the track that we want to use. So the cool thing about this is we can provide track names, so production, beta, internal, alpha. We can also define the user fraction. So when we begin a production rollout, we start at a low percentage just to check things are looking good, and then we'll up it. So here we define 15%. And then if we're using a what's new file inside of our repository, we can reference that from here so that we have the what's new, the new release notes attached to our Google Play release. And once that's done, the final step of the production release process is the Slack message. Couldn't miss that out. So once the upload APK is completed, we're going to simply use a Slack notify action, again, created by the community. This just takes a webhook, an icon, and a few other static strings, and that will, once our upload has been uploaded to the Google Play Store, post a message in Slack so we know about it and we know it's completed. So all of that together, whilst there's a lot going on, hopefully that workflow shows you a collection of things that you can do with Google Actions. And whilst that's quite a complex workflow, maybe you'll do a couple of those things, or maybe you'll want to do more than that. I think that shows that we can have complete workflows for Android and mobile inside of GitHub Actions. The final workflow that I just want to touch on quickly is quite a small one, is one that I actually added last week. So we have the problem on Android and other projects where dependencies change, new versions are released, and it can be quite a manual process to keep an eye on things. Even if we have Gradle plugins, we still have to manually run them. So I decided to create a GitHub action that will run every Wednesday, and it will check our dependency versions using a Gradle plugin, and then it will post any new versions to Slack in a specified channel so that I know of new updates that are available and I don't have to manually check things. So again, this is only a couple of jobs. We have a trigger for a cron specific time using the cron format. And when that is met, we need to retrieve the dependency versions that are out of date. And again, we need to post it to Slack. So we're going to begin by giving it a name called dependency checks. And we're going to use, for our trigger, we're going to use a schedule trigger. And for this, that's my debugging time. It's a very specific time, 58+4. So that would usually be on our repository at the moment. That's 12 o'clock. So it'll run midday every Wednesday. And that will run every Wednesday at midday, and it will run its workflow, and it won't run again until the next time that cron schedule is met. So the first step is check dependencies. And this just runs a Gradle command that we have in our Android project. The plugin is actually a plugin by, I think it's Ben Mains. And what it does is you run check dependencies, and it will just give you all of your out-of-date dependencies, all your a couple of other things, and a bunch of information. And all we've done is we've extended that task, and we just format the output. So we strip all the links and we just format the things that we want to see and remove anything that we don't. But it's almost the same as what comes out of the box. But if you haven't heard of that plugin, it's worth checking out. It's by Ben Mains. And once that's run, we have our Cool. I think it timed out, but we're back. Cool. So once that's run, that will be saved to a file in our Android project, and we're going to then upload that artifact, and that artifact will be added to our workflow, ready for download by the next one. And then in the final step of our jobs, we're going to, again, post a Slack message so that we know about these dependencies. So we check out the code, we download the artifact which is attached to our workflow, and then we prepare the content ready for posting. So what we do here is we get the file, we grab the contents of the file, and we save it to a string. We previously touched on before about uploading an artifact and downloading an artifact so that you can share data between different jobs that are run in your workflow. Sometimes you might want to pass data between the steps. So we have a download dependency update step, we have a prepare output content step, and finally we have this Slack notify step. We want to pass the contents of that file, that string there, to our next step. So for that, we can just use environment variables. So here we create a new environment variable, we give it a name, we pass it the value, and then in our final step for Slack notify, we reference that value and use it for the Slack message. So once that's done, the dependency updates will be posted to Slack. So that's kind of what we're using it for at Buffer. And we didn't have too much to move over. Like we had 3 or 4 workflows, and it didn't take too much work to get it in place. Doesn't mean that it's right for everyone. It really depends the current situation you're in, how heavily invested you are in your current service and how well it's working for your team. It's not the kind of thing you just want to move for the sake of it. So things to point out, the cool thing is if you want to explore GitHub Actions and you're curious, it's free for open source. I know a lot of CI services are, but there's no barrier to entry because there's no cost involved on that front. If you are using private repositories, you'll be restricted on minutes. So, for example, a private repository on the free plan is 2,000 minutes, and you can see from the table, there's more. We're on the team plan, so you have 10,000 minutes a month. Like I said, that could be quite hard to hit, but it depends how big your teams are and how many workflows you're running. Like I mentioned, macOS is more expensive. If you go over your allotted time, then the amount you're charged isn't too high. Again, it depends how much you go over, but you can see on the right-hand side there, pricing is kind of generous until you get to macOS. Just to finish up on some points. So one of the pros of this is I think, it's one less service to depend on. There is the argument of having all your eggs in one basket, but having one less service to depend on, there's I'm still a bit bitter over Buddy Build all those years ago, and we were quite heavily invested in that, and that got bought by Apple and killed off on Android, and it was a lot to rely on. Whereas GitHub is a fairly stable, large company, and it feels a lot more comfortable to be in that place. It also reduced friction. This is a huge thing for me. Like whenever something goes wrong or something fails or something breaks, I'm already in GitHub because I'm already looking at pull requests, and I can see the logs there from the CI that's been running. When I've been in an external tool, it's a lot of hopping back and forth, and there's clunkiness involved there, and it's a cognitive switch. So having it in the same place, I think, makes things a lot nicer to work with, and it's less strain on the mind. You can use existing commands and scripts, like I said. That's why, again, personal preference. That's why I didn't find it too difficult to get to grips with it, because you can just run the scripts you're running locally. Once you've learned, if you're using those kind of scripts, then it makes it quite a bit more frictionless to get involved there. Whereas when I find that sometimes when there's a lot of heavy graphical user interface, it can be quite overwhelming and it can be quite hard to get used to things. But having those the script focus in place is quite a nice approach. And it's likely already available. Like a lot of companies are using GitHub. If your company's using GitHub for your code hosting, it's more than likely you already have access to these tools. And if you're if you have got private repositories, you'll likely already have minutes allowance. So there's a good reason there for checking that out. And there's a growing marketplace. Like there's already a bunch of Android focused actions available. There's a lot more non-Android focused ones, even iOS stuff as well. You can contribute your own, and GitHub have actually got a hackathon open at the moment. You can create your own actions and submit them. And I think you get swag. I'm not going to check that, but that could be a good incentive to have a play around. And our final point is our builds seem quicker. I don't know why yet, but some of our pull requests are 6-7 minutes quicker than when they're being run on a third-party service. Maybe it's the kind of things going on behind the scene, but if there's more to report there, I'll be sure to share it afterwards. Cons, like I said, we've got eggs in one basket. If GitHub goes down, then maybe you won't be able to put out a build, you won't be able to check your pull requests or have the status on there. That's tricky if you need to get a build out, if you need to get a hot fix or that everything's on fire and you need to ship something. If GitHub's down, then that could be a blocker. Whilst on mobile, we can build things locally and it's a bit easier. If you're dealing with web, that could get a bit more complicated. But that's, yeah, having all your eggs in one basket is kind of, it could be seen as a con for some places. But GitHub tends to be quite reliable and more reliable than smaller third-party services, so that could be a relief. Yeah, like I said, if GitHub goes down, you might not be able to deploy changes. Running iOS commands are a bit more expensive in terms of cost per minute. So if you're dealing with Android and iOS, if you're running UI tests and unit tests and doing a lot of heavy workflows, then you could rack the minutes up quite easily. It could be worth looking into things like Fastlane and other things to kind of get around those minute restrictions and try and save some time there. I don't know too much about Fastlane and the pricing, but that is a way around. And that's kind of it. Yeah, I hope that provided a good kind of coverage of what is possible with GitHub Actions and what we're using it for. I'm sure there might be questions about this, but I am going to be putting up a blog post probably next week now about how we're using GitHub Actions, and I will be including these scripts in there. So that will be publicly accessible if people are interested in seeing that in one place. And I'm thinking of doing a workshop on GitHub Actions on remote workshop. So if anyone's interested in getting hands-on with GitHub Actions and building some things, let me know on Twitter, and we'll see if we can sort something out. But yeah, opening this space up now. If anyone has any questions, want to ask things, then there's the chat, and you can put some stuff in there. Cool. Can you explain again how to use secret keys? So inside of GitHub, if you go into the settings of your repository, on the left-hand side, there's a secrets button, and there you can add key value pairs of secrets. So you could have API key as a name, and then you could have the value for that stored as the value for that mapping. And then inside of your action, you can then access this. Where is it? You can then access this directly. Oh yeah, so here you can see where I have Slack webhook. That kind of approach there is just secrets dot the name of your secret, and then that will inject that into your script when it is run. Yeah. Can you host this on your own server like Jenkins? I don't know, to be honest. I'm not sure how open it is. I know that there is an API which is now, I think it went stable the other day. There's a GitHub Actions API, and you can create and you can run workflows. So that is probably, I don't know if it's possible, but it could be worth looking into if you can access it through the API and run things that way. But out of the box, I don't think it's supported. Do you know if it's possible to jump inside the shell of one of the workers? Okay, debug a broken action. I think it is. I think I remember seeing something. I'd have to double check that, but I remember reading something briefly around debugging that could make it possible. On that note, I know that I've only discovered it last week. I haven't had time to look into it. There is a tool that someone's created that lets you run actions locally. So at the moment, I was kind of like running things in GitHub, and having to clean up my commits and stuff, so it's a bit tedious. But there is someone created a tool so you can grab the actions that are in a repository and you can debug them and test them and create them locally, which is a huge time saver and also helps to keep things clean in your repository. So that could be worth looking into as well. Yep, the deck's on Google Slides, so I'll grab a link and I'll put it in the chat, and I'll also tweet it as well. So feel free to grab it on Twitter. Cool. Are there any more questions? Cool. Yeah, like I said, I'll put the link to the slides on Twitter. So, and if you've got any more questions, feel free to follow up on Twitter, and I'm happy to answer them. Cool. On that note, yeah, thanks for coming along. I hope this sort of introduced you to GitHub Actions, and maybe you've got some ideas of how you might use it yourself or in your company. Like I said, if you're interested in a workshop or following up some follow-up chats, feel free to reach out on Twitter, and I'm happy to talk. That's it from my side. So yeah, thanks again for coming along. Stay safe, stay home, and hopefully talk to some of you soon.